You've now seen a variety of limits. In our last video, we looked at a function f whose limit as x approached a point A from the right was equal to 2, and so it looked something like this. And the limit from the left as x approached A was minus 2, so it looked something like this. So we know that the right and the left-hand limits at a point don't have to agree. But they could agree. One of the examples that you looked at was like that, and that was the function that we called g. There, we had the left-hand limit equal to 1/2, so the graph would look like this, and the right-hand limit was also equal to 1/2, so the graph would look something like that. Now, of course, for the purposes of limits, it wouldn't have mattered what g of a itself was. G of a could have been down here, or it could have been equal to the value of the limit, in which case we would have had a dot up here. For the actual function, I think g of a didn't exist at all, but that's okay. That's the great thing about limits, which is that if you have a formula or a function that doesn't exist or doesn't work when you try to plug in some value a, you can still say something about how it behaves near a by taking limits. But sometimes the limits themselves don't exist. So you saw another function, h, where as x approached a point from the left, the limit was perfectly fine, and I think it was 0. But coming in from the right, the value of the function just kept getting bigger and bigger and bigger without bound. So its graph would have had this sort of vertical asymptote as we come in from that side towards A. So in this case, when h doesn't approach any particular value coming in from this side, we say that the limit does not exist. And we'll always write DNE for does not exist. So that's one way in which a one-sided limit might not exist. The function just kind of blows up towards infinity as we come in from one side. Of course, we could have had h going the other way. It could have blown up towards minus infinity, and that would also be a limit that doesn't exist. But in the last function that we gave you, which we called j, that was something that was even more bizarre. So there we had a function, and it didn't get very big, either positive nor negative. In fact, I don't know if you noticed, but it was always between the values y equals 1 and y equals minus 1. But it never settled down. As x was coming in towards the value, hopefully you saw that j of x just kept bouncing back and forth, going up and down, faster and faster, until it just kind of goes haywire as x comes in really, really close to a. So yeah, really weird. We'll try not to give you too many functions like this, but you should be aware that stuff like this can happen. And when it does, we'll also say that the limit from the right does not exist. So we have some really quick review questions for you, and then when we come back, we'll take our right-hand limit and we'll take our left-hand limit, and we'll put them together and we'll have an overall limit. So stay tuned for that.